We ask autonomous AI agents to build enterprise-scale software, but without strict boundaries, they generate unscalable spaghetti code that collapses under its own weight. Take the Kemedar Build and Manage module. It is an orchestration layer designed to transition real estate from a bare plot of land to a fully managed asset. This interface is the user's entry point. They select a project type, like building on owned land or seeking investors, and define the starting path. Behind this menu sits a complex routing engine. Every selection triggers a different path through Kemedar's underlying microecosystems. Procurement requests are invisibly routed to Kemetro. Labor and contractor allocations are pushed to Kemebook. The user interface abstracts all of that complexity. Building this requires a specific stack: a Next.js frontend, a Nest.js backend, and Postgres database, operating as entirely separate repositories. The difficulty in AI-assisted development is no longer generating the code. The challenge is defining strict architectural boundaries so the AI agent does not cross-contaminate the layers. When developers build a system this complex, they often feed a single, massive product specification into an agent like Claude Code and ask it to execute. This diagram shows the result: a tangled, monolithic architecture where front-end rendering and back-end logic are completely intertwined. With database connections bleeding into the user interface, the system suffers from immediate state drift. Maintaining isolated data schemas or scaling individual services becomes impossible. The target state is an API-first, decoupled architecture. The front-end and the back-end must remain completely ignorant of each other's internal logic. To achieve this, we break the monolithic specification into a tripartite prompt, 3 distinct directives that force the AI into architectural compliance. To utilize AI agents at an enterprise scale, architects have to stop prompting for features and start prompting for isolated architectural boundaries. The first component of the tripartite prompt strategy is defining the API contract before any application code is touched. This is the contract, a strict open API REST specification using standardized JSON payloads, such as this build request schema. This document acts as a boundary. The front-end and the back-end can communicate through these predefined endpoints. The prompt dictates the exact operational standards required, including the HTTP status codes, error handling formats, and pagination logic. By forcing the AI to acknowledge this contract first, we prevent it from hallucinating custom data structures during the build. The API contract is the single source of truth. It guarantees alignment for the autonomous agent and serves as the blueprint for both codebases. The second component of the tripartite prompt focuses on the Nest.js backend repository. This diagram outlines the backend mandate. The AI is building an API-first REST service and is strictly forbidden from generating any user interface elements. Instead of rendering pages, the agent's focus shifts to data manipulation and implementing role-based access control middleware. The prompt defines the internal roles the system must enforce, restricting access for an intake admin, a legal reviewer, or a project manager. This forces the AI to handle all complex business logic and state transition validations securely on the server. The backend mandate successfully constrains the AI. It builds a secure, headless data engine entirely disconnected from the user journey. The third component directs the AI to build the Next.js 16 front-end repository. The primary rule here is that the front-end agent is allowed 0 back-end business logic and 0 direct database connections. This interface demonstrates the result. UI components are receivers of the API contract state, not drivers of logic. The agent relies entirely on mock API services to build the interface in isolation, handling data fetching via standardized hooks that consume the existing endpoints. By blinding the front-end prompt to the back-end, the architect creates a purely presentational state machine developed in parallel with the data engine. The ultimate challenge of a decoupled system is keeping complex business states synchronized across the stack. This diagram shows the Kemedar state machine, 24 distinct statuses from new lead to closed exited, propagating simultaneously into the Postgres schema and the Next.js UI. Enforcing identical enums via the API contract prevents the AI from inventing unauthorized states or failing backend validation. This ensures the orchestrator pattern functions flawlessly without requiring a monolithic core to maintain the logic. Shared data contracts, not shared codebases, are the definitive mechanism for orchestrating enterprise applications with AI. This is the workflow in action. We provide 3 distinct prompts to the agent, allowing it to build the backend and front end in isolation, while ensuring they integrate without manual refactoring. The agent acts in strict sequence, first ingesting the API contract, then generating the Nest.js entities, and finally building the Next.js components to consume them. This tripartite execution workflow virtually eliminates schema drift and hallucinated data structures across the repositories. The role of the solution architect is shifting. It is moving away from boilerplate generation and towards designing impenetrable data boundaries. The tripartite prompt enforces the structural boundaries that autonomous agents typically overlook. This shifts the AI's output from fragmented code sprawl towards scalable orchestration.